In this video, I'd like to give an example walking through some of the more basic and common actions we use in Python. So I'm going to begin with an example. We're using the turtle module, and the code below gives one way of drawing a square using the turtle module by repeatedly 4 times, since there are 4 times of the square, combining the motions of forward and then turning left in order to render side lengths of a square. So let's go ahead and run this cell and watch the animation in action. It's rather fast, but you could see that we started out here. We went forward, turned, forward, turned, forward, turned, and went forward. Because there's no 4th turn left command, you can see that my little turtle arrow is still pointing down. It hasn't turned one more time to return to heading in this direction. This is a perfectly acceptable way of drawing a square, but there's an old saying in computer science that if you're ever copying and pasting code, as we would likely do with the first 2 lines of code in order to repeat a process 4 times, then you're not really programming correctly. So what I would like to do is take this code that works to render our square and simply rewrite it in a way that follows better programming practices. Now, the first thing that I would like to do that is a good programming practice is to say, this number 50 that we've used 4 times here is representing the side length of the square. And if I were to take this code and to want to modify it to make a larger or a smaller square, I would have to make 4 separate changes to my code. And the more you code and the longer your code gets, the harder it becomes to be sure that you make changes in all of the appropriate areas. So in Python, and any programming language really, what is better practice is to create a variable that then holds this number 50 and use the name of the variable rather than the literal value to only have to make a change 1 time. So let's see what that looks like. I'm going to add a line of code right at the top of this block of code called side length. Python uses spaces to distinguish separation between your individual words. So if you're naming a variable like side length, something that is 2 words, it's common practice to place an underscore in between the 2 words, which has the effect of not being a literal space, but looking to your eye as though it is a space. So let's create this variable called side length, and let's assign it a value, and let that be the number 50. So this line, too, is the syntax for creating a variable named side length and assigning it a specific value, which is on the right-hand side of the equal. And then what we would do here is change this 50 to the word side length. And for the time being, we need to do that to all of the 50s. And then if we run this code again, we should render the exact same picture. And we see that that's true. But the benefit of this approach is that now if I'd like to make a larger square, say with side length 100, I can rerun this cell, and I only had to make that 1 change, and we now have a whole square of side length 100, all from making 1 simple change. So a very common programming practice is to create variables to represent the quantities that you'll be using and reference those quantities through their variable names rather than their literal values. We could do the same for that 90-degree angle. We could create a variable named angle and assign it the value of 90 and change each instance of the 90 to its variable name angle. And again, no change in the output. Now, what would really be helpful here is to eliminate redundancies in the codes in lines 5 through 11 by using what's called a loop. The current way the computer runs this code is by running through it what's called sequentially, line by line, first indicating whatever is on line 1, then line 2, then line 3, etc. So this sequential flow of control is the basic premise for any programming language. However, there is a mechanism within the programming language to indicate that we don't want to follow that sequential ordering of things. So I'm going to begin by showing you what that syntax looks like and then explaining what's happening as the program executes through things. Everything that I have on lines 2, 3, and 4 are all things that simply happen once, and then there's the code that is repetitive. When we want to do code repetitively in Python, we're going to use what's called a looping structure, and the word we're going to use to repeat a process a known number of times is for. So the syntax we need here is for I in range. Here, we're going to say for, and then we're going to put a colon. And this is telling us to do something 4 times. We then need to select the code that we wish to repeat 4 times and indent it to indicate to Python that that amount of code is the code that is to be repeated. So when we do that, we should comment out all remaining code. It is no longer needed, as the fact that we want to execute this pattern of events 4 times in a row is covered by the syntax we've included on line 5. In short, we have this nice reserved word in Python, for, which is telling us we're going to repeat something a certain number of times. Range of, and then a number here is telling us how many times we want to repeat what's inside the body of a loop. And this I right here is a local variable that we could use within the body of our for loop if we needed to. But for this example, it's what we would call a dummy variable because we don't actually use it. So let's go ahead now. Let's rerun this code and see that we get the same square, which we do, although you'll notice that we finally did that little last line of turning the turtle facing this direction now, eastward direction, because we do all things inside of the loop 4 times. Now the last thing that I would put in this video is that perhaps a good practice, instead of having angle be 90 degrees here, we could create a new variable called numsides and set that equal to 4. And that would allow us to replace this literal value of 4 here with its name, numsides. And we could change the value assigned to angle to be 360 divided by numsides. That is, don't do the work of doing that division yourself, have the computer do that division. This doesn't change anything about the action that's being taken right now. Same square, but it does allow us with one click to change something like 4 to the number 8 and render immediately an octagon with exactly the same code. Which is the beauty of having done this in this properly formatted way.